It's a great pleasure to introduce our next speaker to you, who I think doesn't need any introduction at all, but I'm going to give him a little bit. There's two reasons why I'm delighted to introduce Professor Anthony Seaton, who's Emeritus Professor at Aberdeen, and is probably well known to many people in the room who work on any type of particle. One is that the story Anthony's going to tell you is fascinating, and it's a great tale and lots of lessons to be learned. The second is that when I contacted Anthony 2 years ago and said, would you come and speak at this meeting? He said, yes, of course, but I can't guarantee I'll still be alive. So I'm delighted he is still alive and he's made it. So it's a great pleasure to introduce Professor Anthony Seaton. Anthony, thank you.
Alive, but a bit wobbly. Thank you very much. Thank you also for putting it off 2 years, because this month is the 60th anniversary of my graduation in medicine. And so I look on this as a tribute to my survival to this occasion. I loved Paul's beginning by saying he didn't want to tread on the toes of giants. You'll all know that that's what Einstein said about Maxwell and Newton, except it was the shoulders of giants. And Paul then proceeded to tread on the toes of giants fairly firmly in his talk. And when you think about it, that those two things, sitting on the shoulders of giants, seeing what's being done before and taking it a little bit further, and treading on the toes of giants, which is annoying people who've said something and saying they were wrong, effectively, is the way science advances. And the story of coal is of that exactly. People saying something is the truth, and then other people coming along and saying, no, it's not, here's the truth. And I've played a small part in that in my life. Now, it is a very big subject, and I'm going to give you the absolute barest bones of it. The disease pneumoconiosis, Coalworkers pneumoconiosis, was described 180 years ago in Edinburgh, and it was generally accepted in Scotland that coal miners got black lungs and died of it. And that seemed pretty straightforward. And then it was disputed for years because lots of people said, oh, they get black lungs, but they don't die of it. Well, they do get black lungs. And the next slide shows 3 X-rays. I know a lot of you aren't medical, but the one on the left over there shows a normal lung. And between the ribs, you can see it's dark. And the middle one, if you're close enough, you can see it looks as though it's got measles. The lung has lots of spots in it. That's called simple pneumoconiosis, and it appears like that in coal miners and in silicosis. Not quite the same in asbestosis. And sometimes that goes on to form these big splodges. I could do it with this, couldn't I? I don't know if it works. It makes matters worse. That makes matters even worse. I'm going the wrong way. These big splodges, these masses of effectively destroyed lung tissue. And it's this progression of that simple pneumoconiosis into this more complicated, severe pneumoconiosis, which is known as massive fibrosis, which kills miners if it's allowed to go that far. If you look at the lungs of the miners, the simple pneumoconiosis on the left just looks like the X-ray, really. You can imagine those black spots in it are the white spots on the X-ray, the negative on the X-ray. You can see in the middle of that, there's a black agglomeration of stuff. Those are the lymph nodes to which the dust inhaled is normally drained, and the lymph nodes are sort of immunological defense of the lungs. The dust is drained to them, but some is left around what are called the acini, where the alveoli, the gas exchanging part of the lung is. And that's where the dust accumulates. in massive fibrosis by a mysterious process, which was originally thought to be largely due to tuberculosis complicating it, but then that was one of the giants that was had his toes trod on. Wasn't. It sometimes was, but usually it wasn't. It was probably due to the lymph nodes getting blocked, and so the dust couldn't be drained away effectively. You get this massive fibrosis, which turns out in many cases to be fatal. Now, arguments raged about whether it was a dangerous thing to work in the coal mines, apart from being killed by rock falls and gas explosions and so on, or drowning. Whether the lung disease was in fact a problem amongst coal miners, until about the 1930s and 1930s, when X-rays were introduced, and it was suddenly found that there were all these miners going around with abnormal lungs, some of whom were breathless, some of whom weren't. And the MRC set up investigations, classic investigations, which showed very clearly that mine workers did get lung disease, but it didn't always cause symptoms. So there was a big argument still about that. And then along came the Labour government, hooray, 1945. 1947, they nationalized the coal industry. They ended up with tens of thousands of mine workers with pneumoconiosis, and they had to do something about it. And they started reducing dust levels in the mines, of course, doing what they could there. But remarkably, they also started doing research. And they did not just a little bit of research, they did an enormous piece of research. The most ambitious occupational epidemiology that has ever been done. Certainly at that time, they collected 50,000 coal miners in 25 pits all over the United Kingdom, and they started examining them every few years. They did X-rays, they did lung function, they did tests of they did X-rays, tests of lung function, and recorded their symptoms. And they also critically made estimates of lifetime dust exposure. And for that, there's one of the research technicians working, hanging up the dust sampler in the mines. And all these men were in groups where their dust exposure was being recorded, not initially by that instrument, but that instrument was invented by two coal board physicists, Henry Walton and Bob Hamilton. A horizontal elutriator on the top, horizontal plates on which the large particles were deposited as the air was pumped through it. The right-hand end, there was a filter paper which was weighed before and after the shift and weighed, and the change in weight, of course, was the accumulated respirable dust, the fine particles of dust that the men had been exposed to. This is what made the difference. This made a complete difference to the ability of people to say what the relationship was between dust exposure and disease. And just to summarize the results very, very briefly, these were the results in terms of simple pneumoconiosis, the spots on the lungs. On the x-axis at the bottom, you can see the dust concentration in milligrams per cubic meter, milligrams, not micrograms, milligrams per cubic meter, up to 8 at this end. Up there you see the probability of developing the disease, pneumoconiosis, simple pneumoconiosis, and you can see that there are two lines, one of which represents exposure to highly carbonaceous coal, what they call high-rank coal, very combustible coal, South Wales type coal. The lower one is low-rank coal. So there's a relationship appropriate for a diamond anniversary, isn't it? Carbon. It's the carbon in the coal that seems to determine at least a part of its toxicity. That's quite an interesting observation. For a long time, it was thought that it was the quartz, but it's not the quartz. Although if there is a high quartz, as I'll come to in a moment, that does make a difference. The next question was, is there a relationship to impairment of lung function? And this is exactly the same sort of graph. Here's the dust concentration, milligrams per cubic meter over a lifetime. This is in all 40 years of exposure in the mines to those sort of concentrations averaged out in relation to the risk of having a loss of an FEV1 of less than 65% predicted. So that's a significant reduction in their breathing capacity, an index of obstructive lung disease. And you can see, again, there is a clear relationship between the dust to which a man's been exposed and the risk of having COPD. And that risk was present in non-smokers, critically. It was present in non-smokers, but was not as great, of course, as it was in smokers, as you'd expect. And it looks as though the two pretty well add up. If you smoke and go down a mine, you've got double the risk. So then the question arose, well, what it's due to. And this was another area of dispute. Why do people get this COPD? What's going on? Well, our hypothesis is that it was due to emphysema. And we had collected lungs from 342 of these miners who had taken part in the research. We didn't collect it from all of them because some are even now still alive. But when they died, as far as possible, we tried to collect these lungs from local pathologists. And some of them were inflated and easy to study, and some were not in very good condition. So the numbers were limited, but 342 isn't a bad number of coal miners' lungs to manage to collect. Our pathologists, led by Anne Ruckley, helped by David Lamb, looked at the amount of emphysema in the lungs, and they found that particularly it was the center of the acinus that was affected. It was centriacinar emphysema. And as one way of illustrating this, they said, let's look at lungs of people who have got more than 30% of their lung affected by the emphysema. Now, the emphysema are the white spaces in that lung. If you look at that, you can see that there's this sort of area up there is normalish lung, and all this area around there, about 2/3 of it, is emphysema. And so they looked at the risk of having more than 30% emphysema in the lungs in relation, again, on that graph over there, the bottom, the x-axis, is their total dust exposure in gram hours per cubic meter. It's just another way of expressing lifetime exposures. And you can see the risk of having a lot of emphysema of this type in the lungs related very clearly to the amount of dust to which they've been exposed. Now you're asking, why has he got 3 lines on that graph? Well, the 3 lines represent the influence of quartz. Coal dust always contains some quartz. Sometimes it contains a lot of quartz. The bottom line represents dust which has had a lot of quartz in it. The top line, dust which has virtually no quartz in it. And the presence of quartz in coal dust modifies the risk of emphysema. So if you are exposed to coal dust with quartz in it, you are less likely to develop emphysema. Interesting observation. So what's happening? And vice versa, of course. Quartz causes fibrosis. Coal dust causes some fibrosis and some emphysema. Smoking causes mostly emphysema, but also, as was known in the 1940s and has been forgotten since then, smoking also causes fibrosis of the lungs. So dusts going into the lungs have these 2 separate effects, fibrosis, emphysema. And that is about the most convincing explanation, description of that observation, I think, from any sort of epidemiology. This is the end of the lung. This is where the air comes. This is a terminal bronchiole here, going into respiratory bronchioles here, which alveoli are coming across. And this is where the dust is deposited. And that black dust there is the thing that is stimulating inflammation and causing macrophages to come along to try to remove it, die, and the consequences of inflammation, which, as I say, can go to fibrosis or emphysema, or in coal miners, both. Okay, well, that's all I'm going to say in the time allowed. It is a very big subject. Of course, our observations on coal and the milligrams per cubic meter we were talking about started us thinking about how on earth can air pollution cause problems at such low concentrations measured only in micrograms. And that led to us formulating the nanoparticle hypothesis. So we moved on to looking at air pollution, and that's the subject of another talk. Coal has been killed first by oil, which of course replaced it in many of its uses, then by pollution, but neither of those really got rid of coal. The thing that's getting rid of coal and needs to do it urgently is climate change. It's such a big subject that when I got to the age of 79, I decided to write a book about it. And if any of you, if any of you want to read the whole story, which is fascinating, including the science behind climate change and air pollution, I've got some copies. And all proceeds go to the Institute of Occupational Medicine. Thank you very much.
Fantastic. Thank you, Prof. That was, I never tire of seeing that stuff. It's an amazing story. Thank you so much for coming.
You've all seen it all before.
Any questions for Anthony? Yeah. Frank.
Very, very good, Anthony. Fantastic story. You showed us the lifetime cumulative PM of or dust of coming from coal dust. And then you also put on some data for smoke. Has anyone actually calculated the cumulative exposure of smoke to see if it's anywhere near what coal mining? I'm wondering if it's a simple mass.
Well, it's very difficult to measure the. I think the straight answer is no. But I don't know for sure whether anyone's tried to estimate how many particles smokers actually inhale. I mean, they inhale the particles produced in their mouth and then breathed in. Most of them are breathed out again, but maybe half of them are retained. I don't know. There must be work of analysis of lungs of smokers looking at the concentration of particles in lungs, but I'm not familiar with that work. It's so deadly, smoking, it kills you with cancer, really, and I don't think it's been a big issue how much dust there is in the lungs.
It all comes down to toxicity.
Well, yes, there's a lot of that.
One more question. Ulla, you had your hand.
Yeah. So, coal dust gave emphysema, but silicates decrease the risk. But was that
quartz, not silicates. Quartz.
Quartz.
Yeah.
Did they get another disease instead, or do they just?
Coal miners get three diseases. They can get silicosis if they're exposed to very high concentrations, which is a different disease, subtly different, but it's different. They can get emphysema of the centriacinar type, and they can get Coalworkers pneumoconiosis. Those are the three. Can they get lung cancer? No and yes. Coal miners in general do not have an increased risk of lung cancer, we're sure of that. But coal miners exposed to quartz have the risk of lung cancer related to the quartz exposure that they've had. And Brian Miller in the Institute has estimated what those risks are, but there's a 7% excess risk of lung cancer in people with high quartz exposure. In the coal mining population, that would apply also to silica exposed stonemasons and so on.
Great.
Thanks.
Anthony, little gift.
Oh, how nice.
Take that
Thank
away.
you.
Put with all the other
Thank you.
awards. No doubt. Thank you so much.